Hey guys, I've got another video for you today. We're going to learn some more stuff about parallel circuits. But first, I've got answers for your worksheet from yesterday. So get those out so you can check over and make sure you're doing everything right. I'll put up the answers and then we'll get to the new stuff. Well, hopefully you got all those right. You understand how to do parallel circuits. Let's take a look at this circuit here. Now, at first glance, you might be thinking, what in the heck is going on here? Because you've got a parallel, it looks like a parallel circuit. You've got these nodes and different loops. But then in here, we've got two things together in a series circuit. So at first glance, this might look like it's a lot more difficult, but it's not really too hard. All we have to do is look at this part in here, where the two resistors are together, as if it was a series circuit. So just like before with the series circuit, for this part right here, as the electricity goes through here, we can actually add the two resistors together and analyze this as if it was one big resistor that had a resistance of 11 ohms. So if we do that, we kind of imagine a single resistor of 11 ohms right here, then it just becomes a regular parallel circuit. The only thing that's a little bit different about that is that when you go back and actually calculate what the voltage is going to be, then we have to go back to thinking this as a series circuit. But let's take a look at this. Okay, we've got a 120 volt source up here. So just like with the parallel circuits, as we go through each of these loops, throw an arrow here. So as the electricity goes down and comes through this loop along here, we know that the total voltage drop all the way across there is going to be 120 volts because it has to get back to the battery. So even though it might drop across each resistor, for right now we know that from all the way across both resistors we have 120 volts. Here we've only got the single resistor, so that really hasn't changed from the parallel circuit. We know across here we're going to have 120 volts as well. So we can use that to figure out what the current is going to be in each of these circuits. So get rid of those arrows. Okay, in this circuit down here, pretty simple. We've got 120 volts, we've got 5 ohms, so we take 120 divided by 5. So that tells us in here our total current is going to be 24 amps. All the way across that loop of the circuit. Okay, up here, like we said, we can analyze this as if it was just an 11 ohm resistor instead of two different resistors with different resistances. So here, if we take 120 and we divide by that 11 ohms, we get a current of about 10.9 amps. Okay, so what would be the current in the supply wires up here and, coming out of and into the battery? Well, just like all the other times, we just add the two currents in the two loops of the circuits. So this would be 34.9 amps. And that's going to be the same over on the other side over here. Okay, as far as the power goes, it's just the same as the circuits that we did before. We've got our current right here. We know that if we take the current and we multiply by the voltage, we can find the power. But before we can do that, we have to look at what the voltage is across each of these resistors, because we know that even though the voltage across this entire line from here to here is 120 volts, it's going to drop differently between those two resistors because they have different resistances. So we've got to calculate that. But we know how to do that using Ohm's law. We know that the current right here is 10.9 amps, and so we can multiply that by the resistance to find the voltage drop in each of these. So I change to a red color here so that our voltages show up a little better. So right here I've got 10.9 amps. I multiply that by my resistance of 8 ohms, and I get 87.2 volts here. So for this first resistor, or I guess this is R2, this first one we're talking about though, the voltage is going to drop 87.2 volts. Okay, and then on the other one, we still take our 10.9 amps, and we multiply by 3 ohms. we get a voltage drop of 32.7 volts. Okay, so here, yes, we've got a little bit more complex of a system, but really, as long as you can break it down and go, okay, in this part right here, we need to look at it like a series circuit, but once we do that, we can analyze the rest of the circuit as a parallel. It's really not that more complex. We're just putting the two ideas together. The problems I give you today are going to be a mix of these, and so you're going to have to kind of focus on, what part of the circuit am I looking at? Is it running? Is the electricity running through more than one resistor? Do I have to look at it as a series circuit, or is it a single loop where I can look at it as parallel? So the last step here that we could do is then go through and find the power, and of course we do that just by taking the voltage, like for the power for this resistor right here. We would take 87.2 volts times 10.9 amps. For this one over here, we would take 32.7 volts times the 10.9 amps. And then for this one, since there's only the single one, we would take the 5 ohms times the 24 amps, and that would tell us the power output of each of those resistors. Alright, so get your worksheets, work on those next problems. I'm sure there's some of you that are just sitting there doing nothing. I don't know what to tell you about how you're going to do the problems on the test. This is the time to practice, but we'll go over the answers for the next worksheet tomorrow, and we've got some stuff to learn tomorrow about batteries in parallel.